Hello, everyone. Welcome to another session, Learn Live session. Today, we are going to talk about how we can add AI into .NET applications, services, and more. This is a full coding scenario. I'm going to show several demos of coding. And before moving forward, let me also introduce myself. My name is Bruno Capuano. I'm part of the Cloud Advocates .NET team. I'm a fan of cloud and AI and more. And as I said, we are going to see three main demos. This is all about showing applications, how we can add AI, and how they can see each other. So the first one is a Blazor application. Let's do some web. I'm going to go fast, so feel free to share your comments in the chat and more. And then we are going to do a WinForm chat application. I went online, find a repo with a WinForm and add some cool stuff there, analyzing videos and more. And then we are going to see the eShop support, which is basically a full scenario using local models, doing a lot of AI stuff. So why are we doing this? And why are we focusing on the .NET part of the intelligent application? Because with .NET, we can do a lot of stuff. We can do cloud, web, desktop, mobile, and more. Also, I am going to use both Visual Studio and Visual Studio Code, but you can choose your own IDE to work with. And hey, even if I am doing today everything in .NET 8, .NET 9 is almost here. You can go back to .NET 6 and more. And I am not going to even talk about that you can do this on Windows, Mac, Linux, and everything. So we have an amazing ecosystem. And we know that every app needs to have also some support in terms of observability, resiliency, scalability, and more. We have Aspire to support that. That's why you are going to see how I add Aspire in each one of the demos that I am doing, even if the AI part is the most important. But Aspire helps me to basically get a sense of the logs or the traces. I am calling the right embedding service or the right chat service. So that's why we have this. So that said, let's stop here and let's go to start with this. I am going to start basically adding AI to .NET app. So first of all, as I said at the beginning, we are running today in the AI intelligent applications. So if you go and check our resources, you are going to see a link here where you have also an AI skill challenge, the community gallery with samples. I'm going to share the samples later today, but there is a lot of information to support your journey to the cloud. So let me go here and let's start with my first application. I think I have it right here. So this is a very, very simple, let's start zoom it. This is a very simple, this is the eShop letter that we call. And this is a front-end and back-end application where we have a back-end that shows a list of products, and we have a front-end with basically show the products that we have here. Let me zoom out a little. And we have a search here. And the search is outdoor, is a keyword search. So when we do a search here, we are going to search and find the stuff that match the name of the product with my search criteria, which is fine. But what I want to do here is something like an example, something from rainy days. I want to make this a little more, I want to add semantic search here. Of course, if I ask this is not going to work. We are not ready yet to do this, but this is what we are going to implement now. So let's go back to the code and let's see how we are going to start here. So the key piece that I am going to use is semantic kernel. I've talked a lot about semantic kernel. We talk a lot about semantic kernel in the .NET channel. Please take a look. We have several libraries and frameworks to use AI services. We have the Azure AI Inference. We have semantic kernel. If you are working with OpenAI, we also have the OpenAI SDK, the OpenAI library or SDK. I can't remember the formal name there. So we have different. What I like about semantic kernel, that's why I'm using it today, is that it allows me to change easily and also between models to work with GitHub AI models or Azure AI models or local models. And also at the same time, I can add, there are a lot of external services, a lot of connectors for Azure AI Search, in example, and more that we can use. That said, the other libraries also have their place. They also support switching models and more. So I will invite you, everyone, to take a look at the libraries and hey, contact me if you want to do more. We are planning to do an AI ecosystem for .NET session to explain this. But let's go back here. So first of all, let's add some semantic kernel libraries in my backend project. And as you see here, I am lazy. So instead of going to NuGet package and add it, I am going to directly uncomment the reference, and I'm going to add. And the two most important one are going to be semantic kernel and semantic kernel memory, because these ones are going to allow me, as I said, to connect to some GPT models that I have in Azure AI, and then to create a vector database in memory vector database to store my products. And then we have LinkQ async to write a little more fine code and prompting. We are going to talk about prompting soon. So with this one, let me uncomment this. And once I have this and I build this again, I should get no issues. And if I check my dependencies, my NuGet packages, I will see that in the installed list, I have here semantic kernel, which I said is the best, is the key piece here. And by the way, I'm working with 1.16. The latest one is 1.21. I need to update this. I haven't done this in the past, but hey, that's the first part, add semantic kernel. Then we take a look here, and we have an endpoint. In the product endpoint, we have a search or products that basically use entity framework to list the products, to make a search for the products using the name of the product and the criteria that we put in the form. And I have created here a new AI search endpoint that is going to use the product data context to search for the products, and also a memory context. I haven't added the memory context here, so let's include the memory context in the project. By the way, if you see me looking in that direction, I am checking the comments right now. If someone has a comment, please let me know. So I have here the memory context. So let's add the using of memory context, and let's take a look at memory context also, because this is the key piece that we have here. We start with a lot of pragma warning disabled. Some of the features that we are using in semantic kernel are in experimental mode. So here is the place that I am going to disable this. By the way, you can do this at project level. You can do this in several places. I like to have them here because basically show me that, hey, in this class I am doing this. The whole idea is that when you have this, you know that you're working with experimental features. Be aware that may work or not work in the current state, and also they may change in the future. So what we have here is a couple of things. First of all, we are going to get a couple of information to connect to the service. I have the OpenAI model, the endpoint, the key, the ADA. Then I am going to create a chat service using this, the deployment name, endpoint, and IP key. You can also do this with Azure the form credentials, with integrated security. Then I am going to get and register the completion service. And then I am going to create also the memory builder using embeddings. So this is the important part where we are going to also create finally the vector database in memory, where we are going to store the products. And then the next step will be, okay, let's iterate to the products database that we have and save the product info that we have here in the memory. I am using a memory database. You can use other databases like Quadrant, Pinecone, Azure AI Search, and more. I like that it's super easy to change about this. And also the whole strategy here of, that's my dog. The whole strategy here of saving the products and a vector database may change. I mean, if you change the product, you need to update your index, you need to update your memory. There's a whole lot of things that you can do here. And then we also have the search function. And this is the interesting one, because what we are going to do is when the user requests make a search, we are going to search in the memory, and based on the response, we are going to see if we have an item here, if we have a response, and also if the relevance of the response is bigger than 60%. This is important. When we work with vector databases and we query those databases, not only we get the info from the query, but for each one of the results, we also have the relevance, which basically said, hey, this result is 70% according match your criteria. This result is 92%. Oh, I like that one. This is 15. I don't like that one. So with that in mind, what we are going to do is search the the product database with the product ID and create a text that's going to say the product name, fits with your search criteria, and I'm going to search the relevance also to see what you have. With that, we have this ready to respond. And as you say, it's super easy. And by the way, at the beginning, we are going to do some cleaning, initializing the semantic memory, some services, and more. This is almost done. The only thing that I need to do is I want to add my service, my memory context as a singleton here in the program. So let's do this as I'm using. And also, I need to init my semantic memory. When I have this up and running, the only thing that I need to do in order to check this is change the front end and basically change the endpoint that we are using to use the new search endpoint. You can see here that this is the old one, this is the new one, and we are going to run the new one. So with all of this up and running, let's run the demo again. I will bring the browsers because, yes, it's always open the browser in the wrong monitor. I will bring the browsers here. And if I go for search and I say outdoor again, this time we don't have a response. And if I do something for rainy days, and I think I need to update my, I haven't shared my, store my credentials here. That's why it's not working. So let me go to the terminal, copy path. Let me go to the terminal, not this one, this one. And I need to do some cleaning, and I need to add my credentials to work with Azure AI. So what we are going to do is we are going to do this. So first of all, .NET user secrets init, and then product, and then Azure OpenAI model. I'm using GPT-4o, and the next one are more tricky. So let me do this in another window. So when I have this, I have all of my credentials added, and let's run this again. It's opening in the other window. So here it is. Let me bring it here. I have the list of products, and I am going to search again for outdoor. The first time is going to do outdoor rain jacket. So it's only give me one. And I have here the product, outdoor rain jacket, fit with the search criteria, outdoor with the relevance 0.83, so 83%. But if I ask a question, like an example, something to cook at night, I will have a camping cookware, which is ideal for cooking outdoors. So it's working. If we want to see how this works in the back, we can go back to our memory context, to the search. To the search method. And if we ask a question again, we are going to see that the step-by-step is we're going to find the response, we are going to query the memory, and we are going to have a relevance 0.66. And if we query this, we are going to find the product and respond this, which is kind of nice. It's working, and this is what we want to do. But we are using an amazing model here, GPT-4o. And we can improve this result here, and we can do a couple of other things, because here I can say something like, hey, my name is Bruno. Can you help me with math problems? So if I ask this question in the current code, what is going to happen is I'm going to query, the code is going to query the memory search. We are not going to find anything. Oh, yes, we find something, 70, which is the product that helped this. Let's see. The camping tents somehow helped this. So it's going to give me this. And no, we don't want to do this. We only with math problems and coding in Python. So what we want to do here is basically make our model, make our application only response basically questions that are related to outdoor products. And here we see that we don't have any product here, but we have a response here because, yeah, Bruno, I'd be happy to help you with both math problem, Python coding, and more. So we don't want to do that. Let's fix this. In order to fix this, what we are going to do, we are going to add a system message. So when we create the chat history, when we create the element that is going to store the history, we are going to define basically how this is going to behave. And the way to do this, we can add a system message. And the system message is basically saying, hey, you are a useful assistant. You always reply with short and funny messages. If you don't know an answer, you say, hey, I don't know that. You only answer questions related to outdoor camping products. For any other questions, explain to the user that you don't do that. So this is kind of important because this is the moment that we are going to basically define how the system is going to behave. So I'm going to hot reload this, and I'm going to, let me minimize this, and I am going to, I missed the main question, there it is. And I'm going to share it again, go back here, and ask them the question again. If I ask the question again, we are going to have, let me rerun everything. I think the hot reload didn't work. So let's start again. Find here the search. Hey. And I will do a search. And we have a response here. Say, hey, I only answer outdoor camping product question, Bruno. If you need help with tents or marshmallow stick, I'm your go-to, which is kind of nice. This is what we want to have. A chat that is going to perform, not a chat, a search that is going to only search and answer questions related to outdoor products. But we can do more. This is not a very cool message when we find something. Let's try to make this a little more interactive, a little more beautiful. So in order to do this, before giving the full response here to the client, let's create a cool prompt that is going to say, hey, you are an intelligent assistant helping clients with their search about, and generate a catchy and friendly message using the following information: the user question, the product that we found, and include the product information. With this, we are going to generate a prompt using the GPT. And then with that, what we are going to have is a cool way to basically show better responses. So if I go back to search and I ask for something for rainy days, hey, now we have a better response here. Why let a little rain dampen your fun? Outdoor rain jackets have got you covered literally with some emojis. I like it, but I also want to include the price here. So I am going to pound price. I am going to include the price, include the following information, and price in the response to the user question. Let's see if the hot reload works for me now. And let's ask again the question. Okay, yes, we have it here. And hey, we have the rain jacket at $49, almost $50. So we are doing this. And hey, I also want to include the description, found product price description. With all of this, I can start to improve the output that we have here. And hey, you see that this is nice. This is a way to work and more, but this is kind of annoying to have the application up and running, or maybe stop and restart the application just to improve our prompts. So what we can do here, what I like to do here, is basically go and use an extension that we have that we've seen in the reference, which is called Prompty, that allows us to do all of this in a much better way. The whole idea of Prompty, and let me go here and copy full path. The whole idea of Prompty, open folder. Is that in my products folder, I have here this Prompty file, and there is an extension which is called Prompty. I have it installed here. Let me hide this. So this extension is going to allow me to create files with the Prompty extension, with the Prompty file extension, and then we can start to use them to improve our prompts. And the whole idea here is that this is an example one. I am not going to run it. Don't have time to do the full Prompty. But imagine that I have a prompt here. This is going to use an Azure OpenAI model with the endpoints and more. I can define here parameters like how many tokens I want to use or the temperature and more. I can add sample questions here, sample responses that I expect. And at the bottom, what I have here is my full prompt, that you are intelligent assistant helping Contoso clients, and then include this in your output. Incorporate the question is provided, and I can say also use funny emojis. Incorporate the question, also use funny emojis. So that's the question. Let's do this in the bottom, in the generated response. So with this, what I can do, and this is what I like of Prompty, is Prompty allows us to generate and use code for prompt flow, semantic code, lang change. So we can do a lot of things here, but this is already part of my project. So I can go back here, and instead of doing this, instead of improve the code like this, I can improve my Prompty code. I can use my Prompty code, and this is going to be better because here, what I have is I have my product ID, the product name, description, and price. So I'm going to pass this as arguments to the Prompty, and then I'm going to say, hey, kernel, use this Prompty file, the one that I show you, that is part of my project, and invoke this async. So when I run this one more time, let me go back here, and I do a search, something for cooking, and let's do search. We have here a super amazing response based on Prompty that, hey, I like it because it's super nice, has everything here. And if I start to play around with Prompty, I can do stuff like, in example, hey, I speak Espanol, I speak Spanish, so replies should be generated in English and Spanish. So let's make this work in both scenarios. So if I run this again one more time before moving to the next one, oh, sorry, one more time here. Let's do a question, something for cooking, and let's take a look at the response. We have here, looking to cook up in a storm in the weather window, and here in the middle, ¿quieres cocinar en plena naturaleza? So we have both. And by the way, when we use GPT models or other models, we can easily generate the code in HTML, so it will be easy to show and more. But you can you get a sense how we start with a very, very simple application that was a Blazor frontend and a minimal backend using a DB, and then we have semantic kernel, we have the vector in-memory database, and more. And by the way, I haven't shown the Aspire version of this. Let me show the Aspire version of this. So let me close this one. Here in Aspire, I have the Aspire version. This is literally the same demo. I may need to add my credentials to use the credentials needed to use the GPT models, because we are running with a new tenant here. But the whole idea here is that this is running in Aspire. Let's wait until I have it here. There it is. So this is the Aspire dashboard where I have my products and my store. I can go to the console, take a look at the products. We have everything here, same with the store. So if I open the store here and I do a search and I say something for a rainy day, now it's up and running. We have everything up and running. And if I go to, in example, the traces, I can take a look here in my view how this latest action first go to the front end, then go to the store, then go to the products, and make 2 calls to Azure OpenAI. Why do we have 2 calls? So the first one is an embedding call, because we pick up the criteria, something for rainy day. I converted this to an embedding to make a query in the vector memory. And then when we have the product that we find, we have the second call, which is a chat completion, where we create the fancy response saying, hey, yes, we found this and we are hoping that you like it and more. So the whole idea here is that using Aspire, we can start to take a look what is happening in the back. And by the way, if I have here, instead of a memory database, calls to Quadrant, Reading, or any other vector database, we will see it here. So this is kind of nice because, as I said, Aspire really help us to figure out what is happening, where are my calls, how is it working, and more. And I have here the service name, products, and we can do a lot of things. So this is it for the first part, which is, hey, let's talk a little about adding AI to a Blazor application example, a standard e-commerce application. So we pick up the standard query search and we make a semantic search, a keyword search, and we make it a semantic search, a more natural search. But how about WinForms? This is something that people ask a lot, what we can do with WinForms. So I started to try to figure out what we have, what we can do with WinForms. And I went to the repos and I started to find, okay, I will try to find the easiest chat, WinForm chat that we have. And I find this from A. Green Tejeda, WinForm chat, which I really like because it's a very curated and powerful WinForm application for the chat client. So what I did is I created the backend, very similar to what we just seen, and then I started to add a lot of functionality there. So let me start with this demo. And as I said, I am going also to use Aspire here to run the demo. This is a very simple program, even if I have a lot of projects there. We have two main projects, which is the server, that we have the chat API. We only have one endpoint there to chat. And then we have the front end, which is the WinForm application, which I said I based it on this project. I'm going to share the links of all of the projects later, so you can take a look what we have there. With this, right now, the current implementation, if I go to the server and to the controllers, I have here in the controllers that when I do chat, what is going to respond here is going to pick up the question from the user. There are a couple of entities traveling between the clients and the backends, and it's going to make a char long, the question length, about how many characters are in the question. So it's a very simple one. So if I run this, once again, I'm going to have the Aspire portal somewhere here. First start running. So I have here the portal. Hey, it's opening here. And I have my Windows call here. So if I do 2 + 2 send, I will see your question is 3 characters long, which is nice because 2 + 2, 3 characters. And if I go here to traces, I will see again the form calling the API, and super simple, super basic one. So let's improve a little this one. Let me stop this one. I don't want the eShop Aspire. Let's close this one. Let's improve a little this one. In order to improve this, I am going to once again use Visual Studio Code, and here what I am going to open is I have here my my code snippets are here. So first of all, what I'm going to do, I'm going to go to the server, I'm going to go to the program, and I'm going to start to add some resources. So wait a couple of seconds until Visual Studio Code make everything here. So I have here a very simple app program. It's a web application, add service default, controllers, endpoints, and more, add login. Basically, Aspire is doing this, but I don't know. I think this code is old here. What I am going to do here is I am going to add my chat chat controllers construction, so 02 add our chat. So I am going to add a chat completion service here, which again is going to read the values from the configuration, and we are going to have an Azure AI completion service. With that, once we have this, what I need to do is go to the controller and change a couple of things here. So let me delete from the constructor to the end. And here, let's also do, put myself here so you can take a better look at the code. So let's do sk add chat controller constructor, where I'm going to get the logger, the chat history, and the completion service. And also, I am going to add a response here. And this is the basic code where every time that we call the endpoint, I am going to basically create in the history, add the user message, then add the stopwatch to basically check how much time we're spending there, and run the chat completion service with the model. And that's it. We have everything there. So if I go back to my code here, let me open this in the controller, we will see that we have the latest functionality here. So let's run this. Let's give it a look how this chatbot is using right now a GPT model in the back. Okay, so now I started to open again my my dashboard here. I have the dashboard. Let's minimize this, and I do again 2 + 8. And hey, I'm still calling the wrong endpoint. What did I change? Chat controllers. I think I'm working in a different scenario. So, oh, I went to the chat server init. Sorry, I opened the wrong project. Let me open the right project. So it's not this one. Is this one. This is happen when you are doing live demos. So if I go back here, chat controller, there it is. Yes, there are changes, and we have here chat completion and more. Perfect. So Aspire, probably in the other window. Where is my Aspire browser? There it is. I have my Aspire browser here. I should get my application here. And let's do another question. What is the capital of France? So we have a response here, Paris, where even the baguette are more stylish, and we have some icons here. I am using a system message with this, which is kind of nice. But hey, I did a lot of WinForm back in my day, and I did a lot of images, streaming, OpenCV, and more. And I like about these models that these models are super powerful. And by the way, if I take a look here at the traces, I will see that we have the form, calling the chat API, calling this is the OpenAI, the Azure OpenAI service. But as I said, I did a lot of coding using image and more in Windows. What about this model? What I like about this model, is that they're very powerful in terms of working with images. So what we can do here is something like this. I can do analyze image, and if my client, the WinForm client, it's sending a request, and the request have an image. By the way, this is all basic serialization with bytes, image as bytes. And then I am going to create a text content and an image content and use that for my model. And because I am using GPT-4o, the model is smart enough, I will say, to help me do this. Let's take a look at this. So we have the latest code here also, and let's reveal the solution and run this again. As expected, we have here this. So let me show you, before moving forward, let me show you a couple of sample images that I have here in my demo application. So let me go here, and let me go to the desktop. So I have these images. I have an example. This is my background in a foggy day. This is the foggy day. And I find online a couple of license plates. I like this one, Jedi I am. Then I have, this is a screenshot of me running something in a Raspberry Pi. This is my running crew. So this is a superhero shirt that I used to have in my old office. So what I like to do here, we can do this. We can basically pick one of these images. Let me go to image by 3. This one, the Jedi image. Let me open the Jedi image so you also take a look at what we have. So this is the Jedi image. Go back here, and I am going to ask the model to do this. So extract the text from the image, analyze the image, and tell me what you see. So if I ask this question, passing the Jedi I am image, what we are going to find is, hey, the text read Jedi I am. It's a California license plate with the Jedi I am on it. Clearly, the car owner is a big Star Wars fan. Amazing, the master of the Force. the model not only analyze the image, but also give me context about what is happening there, what do we have there, and how we can work. If I go to the other images, like in example, where is this? Let me try to find the one with the people, with my running crew, and I have more here. So if I, and by the way, if we take a look at the dashboard, where is my dashboard? There it is. And I go for traces, and I see this one. We can see again that it's just the call from the front, from the form to the API to the backend, and analyze this. But we can do a lot of stuff. As I said, we can do plenty of analysis if we want about, let's run, oh, sorry. I close it, forget about that. But let's run this again with another of the images. And let's do this Raspberry Pi. What is this? In what context does this makes sense? So I'm going to ask this question. Let me show you the image so you can take a look also. What do we have? This is the image, which is a screenshot of a terminal showing information about the Raspberry Pi. If I go here, this is the response from the model. This is a terminal screenshot for a Raspberry Pi device running Debian, GNU, Linux 12, Bookworm, yada, yada, yada. We also have the commands running there, which is Olama list to list a model available in Olama. So, hey, it has everything here. It has analyzed the images and give you a lot of stuff. If I ask how many people are in an image or these kind of things, you are also going to see all of this. And this is very, very powerful because out of the box, we have this. One of the demos that I was working, and let me show you, is that imagine that we have information in AI search. I can go here. I can go to my projects. And I think I have this open in my other client. So let me show here. I can have information in Azure AI search, and I can easily, very, very easily show this information in my project. So let me switch here gears a little, and let me show you. This is a GPT-4o model that I have, and I have a backend with information. I have connected this to a backend with products, outdoor products that I have. And if I ask a question around, what do you suggest to go hiking in a rainy day? I changed a couple of things in the backend. They are changing all the time. So let's see if this one works. So when we do this query is also going to say, hey, for go hiking in a rainy day, it's important to choose gear. That it's going to show a couple of things. Oh, let me switch again to the response, but also is going to give me some reference to the products that we are talking about. So let's go to product 19, which is a backpack, or product 4, which is a hiking boot. So I can do this search. And by the way, what we have here, it's basically, let me go to my Azure AI search, which is here. This is Azure AI search. I have the index. And in this index, I have a question like, show me something for rainy days. I think that's what go hiking. So this is the query indirectly to the index. And we can see here that we have the search, and somewhere here, we have the search caption and the information, which is the info product number 4, about product number 4, the prevent. We have all of the info here. So if we want to do this, but with semantic kernel, there is an easy way to do this. Let me open the sample demo, which wasn't working until a couple of minutes ago. So let me go back to my code. And I am going to do the RAG demo. And this is basically the same code that we just seen, but there is a couple of things happening here. So first of all, when we are going to run our query, we are going to connect semantic kernel with Azure Search. So we are going to create the data source, do a couple of cleaning and context information about the endpoint, name of the index, authentication, query type, or more. Also define how many queries we want to resort, we want to use to do this. Also do the vectorizers to basically reconnect this. And then we run the prompt directly. This is literally the same. I am having some issues with this one, as I said, because we are testing the credential ways that is working. So it was working, but we may have something that is not working as expected here. So let me go back here and let me copy the question one more time. So what do you suggest to go hiking on a rainy day? And there it is. Yes, I'm missing some embeddings connection. We changed literally something early today. Yes, the endpoint and embedding, there is something missing there. It's part of the samples. If you have everything up and running, following the samples and the repo, it should work. But because this one is not working, I was thinking, okay, what is another cool one that I can show? And one of the things that we expect to have, in example, in a client, in a chat controller client with the Windows and with the Windows application and more, imagine that we have this scenario. You have a chatbot for an insurance agent, and the agent gets some video from the client. Let me go back to my desktop, and the agent got this video. This is a very simple video. As you can see, there is someone recording a car. There is some bumping here, some scratch there. So in order to analyze this, we can use a model like a GPT-4o or GPT-4o Mini. I think 4o, there's the mileage of the car there. So we can use the model and say to the model, hey, model, analyze this video. Imagine that we are an insurance agent. And once we have this video analyzed, give me information like a scratch here, a bump there. This is the model of the car, the color of the car, and more. How we can do this? How is the process to do this? So I am not going to focus on the front end, imaging that is picking up the video and is sending the video to the back. But here we have some analysis in the back end. Again, it's literally the same demo. But when we have a video, we are going to create a collection of messages for the chat, and when we are going to basically pass the user question. Then we need an array of frames from the video. So we are going to pick up the array of bytes that we have here from the video, and we are going to generate a list of frames. This is physical frames saved on the disk. And by the way, I was trying to do this also in memory. You can do this in memory, so you avoid the disk. But I am going to update the code soon to have another fork with this working in memory. All in memory, no going there. So when we have this, we have the frames of the video. We are going to create a collection, add this to collection with the new image content, where we're going to have the bytes of the video and more. And then we are going to add this to the chat, and we are going to ask the GPT-4o model to respond. What is happening here in the video frames, if someone is interested? So this is a standard, very OpenCV kind of code where we are going to create a directory data, and then we are going to combine the video. By the way, I have the name here. I am hard coding the name, but somewhere there is the name. I'm working with 5 frames. I can add this to the total name of frames of the video or more. 5, I was testing, and 5 is good enough to basically have the info that we need, but probably for longer videos or for more detailed scenarios, you can do this in video ones. So I'm going to save the video, and then using OpenCV, I am going to capture the video, get the frames, add a collection of frames, and with all of the frames that I have here, I'm going to basically can't remember how many frames we have here, but I'm going to count and get the 5 more average videos there. I'm going to save them to the disk, and that's it. So with this up and running, remember that the scenario is to basically send the video. Imagine that you are an insurance agent, or you are someone who wants to do this, and also generate a response for this. So let's attach the video, and before sending the video, I have the video attached. What I have here is a little more advanced prompt. So let me open Notepad. There it is. And here is my Notepad. This is the prompt that I am going to use. As you see, is a little more complex, but we can generate a general prompt for order to do this. I am going to send everything from the client, but this is the prompt that we are going to use with the video. So you are an expert in evaluating car damage from car accidents for auto insurance reporting. Create an index report for the accident shows before. Let me clean this. Let's do this with 3 sections. All right. Sorry, this needs to be here. We see, sorry, I'm prompt engineering on the fly. So we are going to ask for 3 sections here. So the first section is going to have, and the second one. First one is going to include the car details, license plate, car make, model year, color, mileage. In section 2 lists the car damage in a list, and section 3 will only include exactly 6 sentence description of the car damage. So this is what we have. This is what we are going to ask the model to do. So again, I attach the model. This is going to take some time. So let's see if it's working in less than 30 seconds, which I think is my time. Oh, and yes, we have the response here. So we have here car details, license plate, MAT 251. So let's take a look at the video. Somewhere here is the license. Yes, MAT 251. That's good. We have here the license. We have car make Toyota Camry. I think that's the model. We also have the approximate model year, 2010, color dark blue. We can determine the mileage from the images. This is because the last frame is the one that has the mileage, and it's probably not in the 5 frames that you generate. We're going to try with 10 frames to see if it works fine. But let's also take a look at the other responses here. So list cars of the damage, where we have scratches on the rear bumper, dent scratches, and more. So it generates everything, and it works really nice. And imagine that, hey, this is a standard Windows application that is sending information to the oh, sorry, didn't need to close this, to the cloud in order to do that, but we have everything there. So let's change the frames to work with, I don't know, with 10. It's probably going to give me a timeout, but hey, let's give it a try to see if 10 works. So I have here my app host, I have my application. Let's attach the video again, and let's copy the prompt that we curate, and it's here. We have everything, and let's wait. What I found doing this, oh, I think, okay, yes, I know. That's weird. It should work. I don't know why it's filtered. Or someone else is using and changing my content filter in the back, which I hope not. But let's run it one more time. And yes, we have everything here. Okay, so it seems someone is changing my content filter in the back, and somehow they raise the level, and some of the information that I have here in my video is not good enough for the video. So let's also, maybe the video is too long. Instead of 10, let's do 7. Our goal is to try to show the mileage of the car. So it's here, prompt, video, send. Okay, perfect. Still 7 is not good enough. We still don't have the last frame with the mileage there. But we can play around with this to see what we can do. If I do something like try again and get me the mileage, we are going to see that it's probably going to try. Not sure if we're going to get this or not, but okay, yes, we lost that. We don't have the frame with the mileage, but you get a sense of how we can do this. And by the way, minimum changes on the front end, just major changes on the back end. So with this said, let's talk very fast about our final demo that we have today, that is going to use small language models. And the whole idea right now is that we've been using GPT models on the cloud. We can use other models on the cloud, but there is a chance to use small language model, and these are very, very powerful ones. And for this one, we are going to use 3.5. This is a super powerful model. And the whole idea is that we have an application that is a eShop support. We presented this in the AI, in the .NET Conf Focus on AI a couple of weeks or the last month, and it's an amazing demo. So let me go here. I have this demo running in one of my DevBox machines. So there it is. This is my demo, and I don't need this. I need the eShop support. So the eShop support is going to use, once again, Aspire, is going to run the model with Ollama. What this does mean, Ollama is a host of a model. We have Ollama running locally. And once the demo starts, we are going to see that in Docker, we are going to have a lot of new containers running. One of those containers is going to have Ollama, and Ollama is basically going to host the 3.5 model locally so we can use. And this scenario is a scenario where we have there you can see a lot of models here, a lot of containers here. And if I go to where is my chat completion, Ollama, and if I open this in the terminal and I do Ollama ls, we see that we have two models, 3.5 and Mistral. So cool, those are up and running. And if I go to my Aspire dashboard, you will see that we have here tons of services. One of the services is the customer web UI. And imagine that you are a customer, you get a product, I don't know, let's make up a Bluetooth speaker, and you're not happy on how this Bluetooth speaker is working because you can't figure out how to change the batteries there. So once this one is up and running, oh, sorry, I was playing with this one. So yes, continue. When I have here, I can create a new support request about the product. And as I said, I can't remember the name of the product. I know that the product is audio related. So when I do audio, you take a look here that we are using one of our components here, a smart component that is making a semantic search to query the product that we have here. So it's not just filtering based on the name. So I'm going to select one of the products. This is a super cool feature that we have here. Again, a real application. And then we are going to say, I'm not happy about this. I can't change the batteries. How to charge the device. Please help me ASAP. So when I submit this, there are a couple of things that are going to happen in the back. First of all, the staff are going to receive a new ticket, and there is going to be a background process that's going to analyze the ticket, generate the summary, analyze the sentiment, and how happy is the user. Not happy here right now. So let's switch now. I created this today, 10:02, 5:05. So let's switch to the staff web UI. And in the staff, we have working Bob. We are very, very creative with our users. So we have Bob working here. And as you can see, the 5:05, this is the ticket that we have right now. The process is working in the back. So we still don't have a summary. We still don't have a satisfaction level. Let's wait a couple of seconds. But in the meantime, we can start to take a look how this other works. So if oh, there it is. So 5:05, updated there. We have read in satisfaction and one message. And we use one of the models in real time to basically generate a summary of the ticket. So if I go back here, I will see that the customer expressed dissatisfaction, inability to charge battery. The model is also smart enough to be connected to the database with all of the information about the product, so we can query the database using RAG, a super cool technique to do this. So when we have this, the GPT model is going to generate a response. So I can query the RAG. And again, this is all working locally. We are not using a model on the cloud. This is all working locally. That's why it's taking some time. But then we have here the explanation. The citation provides specific guidance for the product user manual, more how to add exchanging batteries and more. It's going to basically show more information here, and I can set other stuff like, hey, give me more info. If I go back here to the ticket, because we are working with a model, with a local model, I think this is Hans. Those models are smart enough also to basically analyze a ticket that was written in German, generate the summary, do a summary also in English, and hey, once we have this, we can start working kind of in a multi-language scenario without knowing Germany. I don't know Germany. And by the way, this is going to take some time, but when the assistant creates a suggested reply to the customer, I can even say, give me the response in German, and I can reply this. So this is another sample that you can use to see what we have, because we have semantic search here, we have summary, we have everything. And again, this is all working using generate the reply in German. This is all working using a local model in this scenario 3.5. So I am going to go back to my slides. I don't see any comments here, no problem. I want to share the links here. And finally, you can see the assistant there generating the slides, the response in German. At any moment, I can use as reply and close the ticket with, or give some more information to the client with the German response here, which is not for me. So yes. Let me go back here to my slide. So this is I am going to ask Anna to share these two links. In the chat, but with this, we are almost done. This is the two main applications that we see, the WinForms application and the eShop support application that we saw during the session. This is literally an example of how you can do it and have it. And thanks, Anna, for sharing the links. And hey, if you have any questions, if you have anything else, it was a pleasure to be here. You can find me there, my Twitter or X or LinkedIn or more. Happy to answer the questions, happy to help you with your going to the AI applications, intelligent application one that we are running. And hey, looking forward to see you in the next sessions. Goodbye, everyone. Thanks. And before I forgot, yes, if you can spend some seconds and give us feedback, we want to know what other topics you want to see, where we can improve and more. Please, this is the link of the Reactor survey. This is the event code 23656. So, hey, thank you very much for being with us, and thanks for sharing your feedback.